All right, in this video, we're gonna look at another way of taking derivatives called the chain rule. And you notice that this one is a specific learning objective in our current unit, but this one's gonna get used pretty much in every other learning objective about derivatives, because this is the one that the AP test is gonna use the most, all right, making sure that you understand how to do the chain rule. All right, the product rule and quotient rule are also important, but this is the one they really almost have in every single problem. All right, so what is the chain rule? All right, so over the last few sets of videos, I learned how to take the derivatives of different functions. We can add and subtract them using our derivative rules. Using the product rule, we can do multiplication. Quotient rule, we can do division. All right, so we can do a lot of different types of derivatives now using all these different rules. But there's still one thing we haven't learned yet, and that's how to do the derivative of a composition of functions. Here, x cubed is inside of the sine function. Here, sine is inside of an exponential function. So when one function is inside of another, this is the only one we don't know how to do the derivative yet. All right, this isn't multiplication, even though there's parentheses. All right, sine is a function, so this x cubed is inside the function sine. So it's the one thing we don't know how to do, and we need a new rule called the chain rule. All right, this is the way the chain rule looks. All right, so we have this g of x function, and it's inside this f of x function. All right, so the way we're going to do this is we kind of work from the outside in. We're going to take the derivative of this outside f function, but we keep the inside the same. So we take the derivative of the outside, but we keep the thing on the inside the same. And then we multiply by the derivative of that inside function. All right, so keep the outside, or take the derivative of the outside, keep the inside, and then take the derivative of the inside. All right, so in other words, you keep the inside function the same, and then just kind of keep working your way in. All right, so here's one example. All right, so we have x cubed plus 5 to the 5th. All right, so we have this big parentheses here. All right, so that's one clue that you're going to be doing the chain rule. You could multiply all this out, but doing a 5th power of polynomials is really tedious and a lot of extra work. All right, but if we recognize that if this was x to the 5th, so I replaced everything in this parentheses here, which is a single x, we can take the derivative of x to the 5th using the power rule, and that is 5x to the 4th. All right, so the derivative of this 5th power here, we bring it down and subtract 1 from the exponent. So we're going to do that same thing, our derivative function. We're going to bring that 5 down, subtract 1 from the exponent. But the only difference now, instead of just having a single x like we did over here, we have this whole thing in parentheses. So we're going to leave that part the same. So we basically just did our power rule where there's something else in the parentheses rather than just a single x. But we're not done at this point when you're doing the chain rule. There's still one extra thing you have to do, and that's where you have to multiply by the derivative of what's ever on the inside. Derivative of what's on the inside is 3x squared. All right, so that's our full chain rule derivative. And you recognize that there's one function inside of something else, and you just work your way from the outside in. So from the outside, the first thing we hit is that exponent. We do that using the power rule. The next thing we hit is that thing in parentheses. That's an introduction to the chain rule, and the next video is just going to be doing a bunch of different examples.